had lemonade before I came in here. It was with that really potent lemonade. So like, no, heartburn and acid just not coming together.
All right, so today we're going to look at the Unit 4 review, just working through problems similar to problems that will be on your test. So what additional information is necessary to show these two triangles are similar? So important to notice that this is this symbol for similar, not congruent. So we're proving them similar by AA. If I'm proving two triangles similar by AA, I have to show that I have two pairs of congruent angles. Excuse me. When I look at these, the first thing I notice, my favorite type of angles happen right here. There's a pair of vertical angles right there in the middle, which I automatically know are congruent. So vertical angles are automatically congruent. I have one pair of vertical or congruent angles. But to prove with AA, I have to have two pairs of congruent angles. So I'm going to look through my answer options, and I've got to show or prove some way, shape, or form that I can get another pair of congruent angles. So looking at question, let's see, letter A, angle G. Letter A says the angle G, this angle here, is congruent to angle IHJ. If I follow from I to H to J, it's talking about this angle in here. If I prove those two angles congruent, will it do me any good? No, because H is or the one in the center is already congruent to the other one it's vertical to. So we know it's not A. Letter B says angle K is congruent to angle G. Would it help me if this angle was congruent to this angle? So I have a pair of congruent angles, but are they from opposite triangles?
They're in the same triangle.
They're in the same triangle. It doesn't do me any good. I want to prove that I have one congruent in the left triangle to one congruent in the right triangle. Let's see. If I have GK, this line here, parallel to IJ, whoops, I can't read. No, they're not. I lied. Letter C is IK. So letter C is telling me that these two lines are parallel to each other. Are they parallel to each other? No, absolutely not. Notice they're really similar except the letters here have been changed. So IK cannot be parallel to GK. So we're going to check the last one. The last one is that GK is parallel to IJ. If these two lines are parallel, we have alternate interior angles here and here. Is that enough information to prove these two similar by angle?
Yeah.
Yeah, we can actually show that all three angles have a corresponding pair in the, or a corresponding angle in the second triangle. So this one has to be letter D by process of elimination. Moving to question number 2. Question number 2 tells us that OM is parallel to NP. What additional information is necessary to show that triangle MNO is similar to triangle PQN by side angle side? So first thing I'm going to do, we're going to talk, oh, that's not very, whoops, wrong thing. This. Close enough. So looking at the two parallel lines they gave us, if I have two parallel lines, I'm going to say they're cut by that transversal there. Sorry, my line's not very straight. If those two parallel lines are cut by that transversal in red, you have corresponding angles here and here. Agreed? So I have the angle O is congruent to angle N, and then everything I do is going to be based off of these two angles being congruent. Because if I'm proving using side angle side, I have to prove that, let me pick up, this side in green is proportional. So those two sides in green have to be proportional to these two sides here in red. The reason being, for side angle side, the angle has to be included between the two sides that you're talking about. So I need to figure out which one of these four options creates a proportion that's reasonable. So when I start looking, I'm going to start at the top of the first one. MN. If I look, side MN, is side MN one of the two sides I care about? That's this side here. Is it one of the two sides I'm worried about?
No.
Absolutely not. I'm automatically marking this one off. I can actually mark off any triangle that has MN in it. Well, what do you know here? Another MN. Oh, wait, and another MN. So already I know the answer is D, but we're going to go ahead and work through why it is D. So here, when we look at letter D, first thing, again, I'm going to check is OM. OM is this left side here. The proportion of OM divided by the corresponding side in P happens to be on bottom, so we're so far so good. When I make my second proportion, I have to start at the same triangle I started with before. So for the first one, we started at OM, which is the triangle on the left. Talking about the triangle on the right, I've got to make sure I'm talking about this red sign down here. ON matches ON. And then for the second denominator, you're talking about this side here. NQ has to line up with whatever's down here, and it does. So letter D is your correct answer. Again, I would just go through, mark what you need to know, and then just check your answers to it. So as soon as I saw letter A had MN in it, and it's talking about this side from here to here, it's not the side you care about, so you know it can't be part of your answer. Same way with PQ. If I looked and had an answer with PQ in it, I know PQ can't be in my answer because it's not, like if I had that side, it wouldn't be the included angle to give you side angle side. Questions 3 and 4. So state if the triangles in each pair are similar. If they are, you're going to state how they're similar by side, 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 angle, side, or angle, angle, and then complete a similarity statement. If they are not similar, if two triangles are not similar, can you write a similarity statement? No, absolutely not. In the past, I've had students tell me that the two triangles are not similar, and then they went ahead and wrote a similarity statement. You can't write a similarity statement if they're not similar. So when I look at question number 3, what do you think we're going to try to prove these similar by? Side, 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 angle, side, or angle, angle? So the two triangles on the left. So you have to decide, do you know information about all the sides, two sides in an angle, or two angles? We were given links of all three sides of both triangles. So we're going to try to prove this similar by side, side, side. To prove two triangles similar by side, 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 we need to take and find the proportion for all of the sides. So again, I always start with the smallest side first. So looking at the triangle on the left, the smallest side, I have 8, 12, and 24. Smallest side is 8. I'm going to take that 8 and I'm going to divide it by the shortest side of the second triangle. And that would indeed be 6. That gives you 1.3 repeating, or 1 1/3, depending on how your calculator spits it out or how you simplify it.
1.33.
Yep. So there's our first number. We're going to keep this number in mind because we want all three sides to have that same proportion. So I'm going to go to the next side. Again, I started with the smallest side. Now I'm going to move to the middle. It doesn't matter which order you check these as long as you check them all. So the
24 and 12.
you can do 24 and 12.
I got it 2, so it doesn't match with the first one.
You got it. So let me.
And then 12 divided by 9 is 1.3.
Repeating. Yep. So here we found all three side proportions. Remember, they all three have to match. Do they all three match? No. So this is not similar. Can I write a similarity statement? No, please don't. They're not similar. You can't write a similarity statement. Keep that in mind on your test. If you tell me it's not similar, you are not writing a similarity statement. For question number 4, we were given 2 sides on both triangles. That leads me to believe I have to use side angle side. The first thing I want to do, can I prove 2 angles congruent to each other? Remember, my favorite type of angles are vertical angles. Vertical angles happen at any intersection opposite of each other. So here in the middle at N, I have 2 vertical angles. One belongs to the triangle on the right, one belongs to the triangle on the left. They have to automatically be congruent because, again, they're vertical angles. So I've got my set of angles. Keep in mind those angles are included. They're between the 2 sides I know on this triangle and the 2 sides I know on this triangle. So I'm going to go to see if I can prove by side angle side. To do this, we have to make 2 proportions and make sure they're the same. Do not get confused. A lot of students want to pick and just circle these 2 and put these 2 together and these 2 together. Not how it works. It's why we always pick smallest and smallest. So if I pick smallest of the triangle on the left, I get 5. Smallest of the triangle on the right, notice, is up here. These 2 go together. 5 and 10, which reduces to 1/2, or 0.5. The
5, 10 divided.
5 divided by 10 is 1/2.
0.5.
That's 1/2. You're right. The second one, if I pick the other pair of sides I know, I have 6 divided by 12. Well, 6 divided by 12 is also 1/2, or 0.5. So these are similar by side angle side. We've proven 2 sides similar, and we can show that the included angle is also the same. So since we've proven these similar, we have to write our similarity statement. So I'm just going to go down here to the bottom. I'm going to say triangle. Let's go with QNM. Sure. Is similar to triangle what? So Q was located between the unknown side and the shortest side. Not quite. Close. So when I picked Q, Q was between the unknown side and the shortest side. So over here, I have to go to the unknown side, which is here, and the shortest side here, which leads me to O first. Oops, yes. So O, then we went down the shortest side to get to N, then P. So triangle QNM is similar to triangle ONP. Question number 5. We were told that the 2 triangles UVT and URS are similar, then we're being asked to find X and find Y. So to do this, I'm going to take and draw myself two separate triangles. So I'm just breaking these two triangles apart. I'm going to have the little one and the big one. Then I'm going to label, let's see, this is 20, this is Y, X, 3. Be careful, when you go to label the big triangle, here on the right side, I mean the left side's a little bit easier. Left side, if I want to find the entire length from R all the way to U, I have to add the two pieces together. So the whole left side is 9 plus 3, which is 12. So when I go to my big diagram of my big triangle, I'm going to label that whole left side 12. Similarly, when I go to label the entire right side, I have to add these two together. These two don't look so great when you add them together, X plus 12 or 12 plus X. So really, we're going to have to make two proportions. Remember, if two triangles are similar, their sides also have to be proportional. So I'm going to pick, let's just go with these sides, and then we're going to go with our second proportion for these sides. So I'm going to make my proportion 20 over Y equals the pink numbers. I'm using 12 for the big triangle, 3 for the little triangle. And then indeed, I am going to cross multiply. So here we just have a proportion. Proportions are best solved by cross multiplying. So I'm going to multiply 12 times Y to get 12Y. And when I cross multiply the other direction, I'm taking 3 times 20, which is 60. Yep, divide both sides by 12, and you get a Y value of 5. That is one of my answers. To find the second one, we're going to do the exact same thing we just did, except we're not going to use the 20 and the Y. We're going to use the 12 plus X and the X. So the big triangle was 12 plus X divided by X. And again, I'm going to use that 12 over 3 all over again. So now when you cross multiply, you have to be careful. When I multiply this way, 12 times X is 12X, no problem there. But when you cross multiply this direction, this 3 gets multiplied by the 12 and the X. So 3 times 12 is 36, and 3 times X is 3X. Yes. So subtract 3X from both sides. So 9X equals 36. Beside it, divide both sides by 9. And X equals 4. Questions on this one? I've had students in the past who don't separate their triangles. If you're confident not separating them, that would be okay. It's not required that you separate them. Same way on this next question. Again, you don't have to separate them. I just do because it makes things clearer. So when I separate these, the big triangle has a right side of 8. We weren't given any information about the bottom, and we weren't given any information about the whole right side. We're actually being asked to find CB, which is the entire right side. So I'm just going to go ahead and put an X there because that's what we're trying to find. Be careful with the little triangle. When I go to label the little triangle, we have 5 on the bottom, 3 on the right, but there's nothing written up here to tell us the left side. So there's nothing here to tell us the left side, but we have enough information that we can find it. We know that the entire left side here is 8, and this little piece down here accounts for 2. If I have an entire length of 8 and I'm taking away 2 to get to that shorter side, I know that this side must be 6, because 6 plus 2 would give me that entire length of 8. So now I'm going to just make a proportion. Notice you have kind of extra information. This 5 is not needed. We don't know anything about this bottom here when we're not being asked to find anything about it, so it's just extra information to us. It doesn't do us any good. It doesn't hurt us unless we use it in error. So I'm going to make my proportions. Again, I normally tend to start with the triangle on the left. So left side of the left triangle is 8. The left side of the right triangle is 6. For the other portion of my proportion, I'm going to do the right side divided by the right side, x divided by 3. Then we're going to cross multiply this way. So 6 times x is 6x. 8 times 3 is 24. Divide by 6 to get your answer. So here it's not really the math that's the problem, it's setting up the problem that tends to be the issue. So you've got to take those two triangles and separate them, fill in the appropriate spots to create that proportion like we did. Questions on this one? You good? Okay. All right, question number 7. We have Jamie designing 2 sandboxes shaped like similar triangles. We have one with a perimeter of 50.4 feet and the longest side 18 feet. He wants the longest side of the second sandbox to be 12 feet. What is the perimeter? We're going to set up a proportion. Sometimes it helps if we draw ourselves a picture. Again, I don't know who in the world would make 2 triangles for sandboxes, but whatever. So the first sandbox, the biggest one, had a side of 18 feet and a perimeter of 50.4. The second triangle had a longest side of 12 feet and the perimeter is unknown. I'm just going to say X. really all you have to do is set up a proportion. So I'm gonna do longest side of the big triangle is 18. Longest side of the little triangle is 12. Keep in mind, if two triangles are similar, their perimeters also have to be proportional. So for my second proportion, I'm taking the 50.4. So the perimeter of the big triangle divided by the perimeter of the little triangle. Well, we don't know the perimeter of the little triangle. That's what we're trying to find. So here's my proportion. I'm going to cross multiply. So I'm going to multiply these two together. 18 times x is 18x. And then I'm going to take 12 times 50.4. And I believe that gives us 604.8. Yes, it does. Then we're going to divide both sides by 18 to get x by itself. So x, which is the perimeter of the little triangle, must be 33.6 feet. So the perimeter of the second sandbox is going to be 33.6. Question number 8. Question number 8 says a particular Egyptian pyramid is 82 feet tall, but the length across the base is unknown. So we're going to draw ourselves a triangle because we have a pyramid. It's crooked, but it's fine. So this pyramid is 82 feet tall, and the length across the base is unknown, so I'm going to put x. There's a scale model of the pyramid that's 8 feet tall and has a length for the base of 2.4 feet. So I'm going to draw myself another scale model of my pyramid. This one, however, is 8 feet tall and 2.4 feet across the base. Any idea what we're going to do next? Yep, so we're going to solve for x by setting up a proportion. So take a minute and see if you can set up your proportion for this problem.
Is it like the same steps that we did in the first one, or on number 7?
Exactly the same steps as number 7. So again, once you get this set up, it shouldn't be a terrible problem to actually solve.
Can we divide 8 by 2.4?
You can do it that way as long as you're consistent for the other side of your proportion. So you said you took 8 over 2.4?
Yeah.
So you did the height of the little one divided by the base of the little one. So for your second proportion, if you're doing it that way, you have to do the height of the big one, which is 82.
No, like I did 82.
Did you make your proportion? Did you have a fraction equals another fraction? What was it? Can you read it to me?
The 82 over 8, and then equals the 2.4 times the bottom, and then which is all I did opposite way.
Oops. So you did 82 over 8, which is right. So height of the big one divided by height of the little one. When you go to the other fraction, you have to remain consistent. So the 82 came from the big pyramid. So when I pick the numerator over here, I have to pick the x for the base of the big pyramid. I think you flipped them. Did you write the 2.4 on the top or the bottom?
The top.
Okay, that's what it was. So 82 is the height of the big triangle. So for my other fraction on the right side, I have to put the height. Well, no.
So it's 8x,
Yes.
and then it's 82 divided by
Multiply.
or
Yep, you're going to multiply your proportions. So you're going to take 82 times 2.4. The tricky thing is there's more than one way you can set up this same problem and still solve it correctly. It's like we could have,
196.8.
yes. So you have 8x equals 196.8. Divide both sides by 8 to get 24.6 feet.
So then it's 196.8 divided by 8.
Mm-hmm. Because you're dividing by 8 to get rid of that 8 that's in front of the x. So that tells us that the base of the actual pyramid is 24.6 feet. Question 9, which of the following two trapezoids are similar? What is the scale factor from trapezoid A to trapezoid B? That means pick a side on trapezoid A. The 21. If I pick the 21, I have to pick the 35. So when I make my fraction, I need to take trapezoid A side length, which we just said was 21, divided by the side length of trapezoid B that corresponds, which is the 35. And I'm just going to take 21 divided by 35 in my calculator. And what's it tell you?
0.6.
0.6, which is letter B. Questions on this one?
Wait, but it says 0.6.
It's the same thing. So you can add, I can add as many zeros out here as I want.
That will probably confuse me.
I mean, it's the only one with a 6 in it, so you're good. And then the last one is referring to what we did yesterday. So graph and label a polygon JKLM and its image given the dilation K equals 2. The first thing I want you to do is graph those 4 points you are given. So we're gonna graph them and then we're gonna label them. So when I graph 3, 5, I'm starting at the origin, I'm going right 3, turning and going up 5. And that's where I'm gonna put my point. Once I place that point, I'm gonna go ahead and label it J because that's what I was told it was. Then I'm gonna go to the next point K is 5, 6. So again, I'm starting down here at the origin. That's always my starting point. 5, 6, positive 5 means go right 5. And then I'm going up 6. And then I'm going to label that K.
So if it's minus, we just go downwards instead of upwards?
Yep. You got it. So for the next one, letter L, we're going to 2, negative 1. So I'm going right 2, down 1 because it's negative. And then I'm going to label it L. And then letter M, I'm going to 6, negative 2. So I'm going right 6, down 2, and I'm labeling that M. Then we're going to connect these 4 points to make our polygon. We're connecting them to make our figure. Should look something like this. Now that we have that drawn, we need to figure out our dilation in our new ordered pairs. So here we were given a dilation of K equals 2. That means the original figure is going to be 2 times larger, in this case, than the original. To figure out the new ordered pairs, J prime, K prime, L prime, and M prime, we're going to take each one of these ordered pairs and we're going to multiply it by 2. So if I take the ordered pair 3, 5, and I multiply both terms by 2, 3 times 2 gives me 6, and 5 times 2 gives me 10. So J prime, the new J value, is going to be at 610. For letter K, K was originally at the ordered pair 5, 6. I'm going to take that ordered pair, I'm going to multiply it by my dilation, in this case 2. 5 times 2 is 10. 6 times 2 is 12. So K prime, the new K value, is going to be at the ordered pair 10, 12. Next, I'm going to letter L. I have the ordered pair 2, negative 1. Both terms get multiplied by my scale factor of 2. 2 times 2 gives me 4. And 2 times negative 1 gives me negative 2. That's my new L prime. Then the last one, letter M, is at 6, negative 2. I'm going to multiply both terms by 2. 6 times 2 gives me 12. And negative 2 times 2 gives me negative 4. Now I'm going to go through and I'm going to plot all 4 of these ordered pairs. When I label them, they're not going to be J, K, L, and M anymore. They're going to be J prime, K prime, L prime, and M prime. So when I graph J prime is at 6, 10. So I'm starting at the origin. I'm going right 6 and up 10. To graph K prime, I'm starting at the origin. I'm going right 10, up 12. To graph L prime, I'm starting at the origin, going right 4 down 2, and I'm labeling it L prime. And then M prime is at the order pair 12, -4, all the way down here. And then again, I'm going to take hopefully a colored pencil and connect these so I can see my two figures. The two figures, again, should just be a dilation. One should be larger than the other. The shape shouldn't be changed, just the size. It's like taking and magnifying something and enlarging it. The shape remains the same, but the size has just gotten either larger or smaller. And then the last thing, is this dilation a reduction or an enlargement? Explain our answer. So is the original to the one we just finished a dilation of enlargement or reduction? So did the second figure get bigger or smaller than the original? It's bigger, so it's an enlargement. The easiest explanation to me would be that because the scale factor was 2. Or you could tell me the K value is 2. There have been students in the past that tell me that the second figure you drew was bigger than the first one. Keep in mind that you will have a reduction if you have any K value between 0 and 1. So if your K value is 1/2, you would have a reduction. If your K value is 3/4, you would have a reduction. 8/9. Any number between 0 and 1 would cause you to have a reduction. Anything larger than 1, in this case 2, would give you an enlargement. On the next page, you will find, actually next 2 pages, you'll find a pre-test for your test. Take a few minutes and work through that.